Hello, in this video let's discuss third question of today's contest. You are given a string s consisting only of ABC. A substring of s is called balanced if all the distinct characters in the substring appear the same number of times. Return the length of longest balanced substring of s. N is up to 1 if I and s has only ABC. For example, if the string is ABBAC, the answer is ABBA because it is the largest string such that it contains AB and both with same frequency. So largest substring with distinct characters are same count and n is up to 105. So why they gave the string contents of only ABC? So that we can find all the cases separately. So what are the cases where we can find the answer? So the substrings can be only A or only B or only C or only AB, AC, BC or all ABC. Right? So if there is no restriction that string has only ABC, then we can't do this for every case. We can do, but the time complexity will increase. We can try to do some 2 power 26 time of operation number of times, and then we can do. But here we only have ABC, so we can get these only 7 cases where only A, only B, only C, or double characters and triple character. So find the maximum length for all the scenarios and return the maximum of all. So how can we find it? So firstly, let's come to easy case. So how to find the largest substring that have only A or only B or only C? So let's come to A. Only for A first. And how to find that? It is very simple, right? Let's start from first one. If that is A, then add to the answer. Like maintain two variables. One is the maximum answer and one is the current substring length. Because we want the maximum answer, and only by maximum answer we can't find the present substring length. So it is better to store both maximum and the present substring length continuing till the present index, which is A. So initially the maximum length is 0 and the substring current is also 0, and start from A. So start from A, this is A. So what can we do? So simply increase the substring count. So now the current substring length which is ending at present index is 1, and now go to next index. This is also A, so this will increase. So this is 2, this is 3, this is 4. So now the maximum is 0 and the present is 4. And now we will come to A, like we will come to B. Is B equal to A? No. So if there is any substring which is ending at before index with some length, that will be broken now because new character which is not A been found here. So now update the maximum answer to the substring and make this 0 because we did not get a new substring ending at present index. So continue not A, continue not A, and now again we came to A. So increase A, increase count 1, and then go to B. So here B, again we found a character which is not A. So simply break, simply make the count 0 and update the maximum answer. So maximum for unknown which is 4, so no need to update. And then continue 0, 0, 0, 0 and 1 again, 0, 1, 0, 0. So finally 4 is the maximum substring length where it contains only of character A. So by very easily we can find the answer for only A or only B or only C, right? So these three are solved, only A, only B or only C. And then let's come to AB. So coming to AB, this is not very easy as only A or only B because we have to maintain the count of both, right? So firstly, what is the length of a string that we are searching for? If in the before case we only want A, so there is no restriction on length, right? Because we'll simply traverse the whole array and based on the counts we can find. But here, if we have only AB, can length 3 be existing where A and B are equal? Like A and B are existing and count is equal? No, right? Because A and B should be equal, so it should be some kind of 2 into even length. So 3 length cannot be existing where A and B are equal. So A is equal to B. It means that 2 into X. So even length string is only possible. So now we got half scenario where this is possible. So search all the even strings and find the frequency if A is equal to B. Should that be done? No, because it will be n square, right? Let's say we are at index 0. If we are at index 0, we have to traverse all even length strings 2, 4, 6, 8, and then by some criteria we have to find the frequency of AB in that, and there should be no C also. So all these should be taken care. And even if they should be taken, like even if they are taken care, the time complexity will be n square, because at every index we have to travel n approximately n number of substrings, which is n by 2. So this we cannot do this. So there should be some kind of other idea where when we are index I, we have to get the maximum index j such that I to j is the maximum length possible, and it contains only AB, and AB only the frequency are same, like only AB are existing and the frequency are same. So there should be something like that, else the time complexity will be n square, which we cannot do. So can we do some binary search or O of 1? Because we're at index I, the brute force is we have to travel all the even length substrings. But what if there is some j which we can give this in of log n or of 1? Maybe we can apply binary search on length, but no need to think of more, because there is very simple hashing that can be used. So what is it? Let's say this is the substring where this is a possibility of our answer for AB. So for example, if this is a string where this is the maximum answer, this is the maximum length, such that only AB are there and A is equal to B. So if there is something like that, can we find that because we are traversing the whole string? For example, if we are at index I, is there a possibility to find a before index j in O of 1 such that the substring between j and I is automatically satisfying the condition where only AB are existing and count is equal? Can we check that? Let's assume that we are able to do that. So this is the middle string. So this is I and this is j. So A, B are equal and A is equal to B. So if this is the case, then what will be the total count of AB from 0 to this index where we are? Because we are traversing from 0 to n, right? For example, if we are at index I. So when we are at index I, we already traversed the before indices. So when we are at I, if we try to find some index based on some conditions, if this is j, so we found ij correct. So if that is correct, that should be the substring between I and j should be satisfied answer. What is the condition? So only A and B are there, and count of I is equal to count of B. If there is something like that, then we can traverse everything and we can get the index and we can find the answer in of 1, right? So what is that condition? What is the criteria where we can get? For example, we are at this index. So when we are at this index, if we assume there is a substring ending at the present index, so this is a substring ending at present index, which is good. So how can we find this index in of 1? So what if we try to store the counts? So initially we are at 0. What if we try to store the counts? So here A and B are equal. So what is the count of A and B when we are at this? So from 0 till the present index, what are AB? Let's assume they are A1 and B1. So initially this we are at here. So we are assuming that there may be some index J such that A and B are equal. So if that is the case, then what are the count for A and B? Let's assume that A1 and B1. They may or may not be equal, right? So A1 and B1. So if that is the case, then what are the counts till J? Because these are AB, these are A1 and B1. So what is the count for this? It will be simply A1 minus A and B1 minus B, right? Because we got the total and we got half. So what is the remaining? Simply difference. So A1 minus A is the frequency of A, B1 minus B is the frequency of B. So we can find J if there is some criteria like A is equal to B, right? So B1 minus A and A1 minus A. So what is the relation between these two? What is the relation between A1 minus A, B1 minus A and A1 B1? It is the difference, right? So the difference of this is also A1 minus B1, and the difference of this is also A1 minus B1. So from this what we got? So from this we got that if we are at index I and if we store the count of A minus count of B in some hash map, let's say we have MP of 3 is equal to 4. MP of 3 is equal to 4. And now this substring is good. So they are both AB and both are equal. So even when we are coming here, the difference will not change because 2 extra A came or 2 extra B came. So the difference is 0 overall. So the difference is 3. The difference is 3, not 4, sorry. The difference is 3. And which is exactly the difference here. So when we are reaching here, the difference is 3. So we can get in the hash map, right? MP of 3 is equal to 4. It means that at index 4, the difference is already 3. And at index 10 also, the difference is already 3, is also 3. So the middle answer, the middle substring is an answer. So we can find the answer in of 1. So in this way we can find the answer for AB. So we can store map of count of difference of A minus count of, sorry, difference of count A minus count B in a substring in map. And when we are reaching an index, whenever we are reaching index, we can get whether the difference is already there in the hash map or not. If there is already the difference, then find the answer. If there is no, then add to the map, right? So we got the answer for AB, similarly for BC, and similarly for AC. So we can, so if I have two indices of AB, we can find the answer, right? But what is the guarantee that there is no C in that? So we can filter those, right? So we can simply continue only if they are like, if they are not n, we can check this in the code. So from this what we got, we will use the map of difference of count A minus count B. So if there is any future encountering the same difference, then we can use the index and we can find the middle substring as answer, we can find the length. So now we got these three also. We got only A or only B or only C also. What is the only thing left? The only thing left is ABC. The substring with which is containing all ABC with the same difference. So how can you do that? So even now let's try to find the same case. So we are here, we are at index A. So we are assuming that there is some index J such that in between A is equal to B is equal to C. So all are equal, A is equal to B is equal to C. So how can you find that? So even now let's try to find the count of ABC till now. So let's assume that it is A1, B1, C1. So we got the whole characters count. And now if these are equal, then what is the count till before? It will be A1 minus A. It will be B1 minus A because all are equal, right? And C1 minus A. So what is the relation? What is the relationship between these three and this? If we clearly observe, it is the pair of difference, right? So if we assume that similarly to the before one, if A1 minus B1, right? If A1 minus B1 is same for both, but is this a valid criteria for comparing? No, right? For example, if A is equal to 3, B is equal to 3, C is equal to 4, and for present A is equal to 3, B is equal to 3, and C is equal to 6. Let's assume that these are 4, 4, 6, right? So even now the difference of A is equal to 1 is equal to difference of B1, right? So can we compare that these have ABC equal? No, because we have to check C also, right? Because C also should be same. If C is also 5, then we can say that middle substring have only one ABC. So this is correct, right? But here only one A1, B1 we cannot check. So we want some kind of pair which is comparing AB and which is comparing BC or AC also. So that we are able to check the condition for all the three. So with A1, B1, we have to check B1 minus A1 also. And how can we get a single hash value based on these two? So if for example 2, 3, if we have 2, 2, we have to get that there is substring of, like there is substring ending at some index with this difference. So simply we can use pair, right? So we can simply pair of difference of AB comma pair of difference of BC, and this we can store in the map. So whenever we encounter the same difference previously in the map, then we found the answer. Let's take an example, right? So this is AA, this is a BC, right? So this is ABC. So initially we are at A. So what is the difference of AB? It is 1. What is the difference of BC? It is 0. So 1, 0, comma 1. So the difference between A and B is 1. Difference between B and C is 0. And the index is 1. Index is 0, sorry. And now let's start traversing from this. So count of A is 2. So the count of A is 2. B is 0. C is 0. So is 2 comma there in the map? No. There is only 1 comma 0 in the map. So add this to the map. So we got a new pair 2 comma 0 with the frequency with the index 1 at index 1, and now come to 1 at B. So count is A, count of A is 2, count of B is 1, count of C is 0. So the difference is 1 comma 0, right? So 1 comma 0, and then which is 2. This is the index 2. So we can try to store some minus 1, right? Because there is no C. So we can try to store some kind of minus 1. And now coming to C. So we are at ABC. So the count of A Sorry, we can just store 0, but the difference is 1 because b is also 1. So a minus b is 1, b minus c is also 1. So there is no till now. So 1 and 0 is 0. So 1, 1, 2. And now when we reach c, the a is 2, b is 1, c is 1. So the difference of a b is 1, difference of b c is 0. So is there already 1 0 in the 2? Yes. So it is 0. So till this index, we got the answer. So that means that middle is a possible answer. So which is ABC, which is a possible answer. So in this way, we can try to store hash map of pair of differences, and then we can check whether there is map in it is there in map or not. Then we can find the answer. So encountering same pair, and then we can simply return the answer. So let's check a sample code for AB, only AB. So we discussed that how to find whether there is no C or not. So we can continue only if either of A, B are there. So if A is equal to A or only B, only then continue the map. If that is not, then simply go to next index. So in this way we can check only A, B there or not. And now we want that difference, right? So difference of A and difference of A and B. So if this is A, then we can add 1 to the difference. If it is B, then we can add minus 1 to difference, which is indirectly like comparing the difference, right? For example, we have A minus B and we got A. For example, we got A again, and then we got B. So instead of maintaining two variables, what if we can maintain very single one variable and update both in those? How can we update? So if we get new A, then this will increase. So we can just directly increment the difference by 1. And if we get a B, then decrease by 1. So simply reduce. So by single variable P, we can find the difference. So if that is X, then add. If that is Y, then decrease. And now find in the map. If there is already in the map, id not equal to n, it means already in the map. If there is already in the map, then simply find the difference of the integers, which is length. So simply j is the present index minus id of second, which you stored in the map. So this is the result. Middle substring is the answer, right? So this is the answer. If we did not find the answer, then update the present difference to present index, so that this will be useful for future, and simply increase length. Increase the index j. If we observe one thing, for example, we are at 2, we already got the answer for 2. Like there is already index for 2. So are we updating 2 to the present index? No, because that is very bad decision. Because for example, in the future also, if we get a difference 2, then which is better? This is better or this is better? Obviously this is better because this is the largest length. So whenever there is a value already existing in the map, only update the answer. Don't update the map, so that we'll reduce our answer. So if map has already the value, then don't decrease, like don't update, then just update the answer, don't update the hash map. Let's check the code, which is very same as before. So function 1 of all these, function 2 of ABC, and function 3 of only single. So let's check function 3 very easily. So only A or only B or only C. If that is equal, increase current, else current is equal to 0. And update the result and return the result. And now coming to AB, BC or AC. So we will traverse till either of it we reached. If the first string is C, then we will continue, right? Like if we will reach until A, B are there. So simply skip all the characters and then map of 0 is equal to I minus 1. Why I minus 1? Let's say we started traversing. So initially when we are at this, the count of AB is 0. So the difference is also 0, right? So when we are 0, we can assume that map of difference is 0 because there are no characters, so difference is 0. Map of 0 is equal to I minus 1, which is minus 1. So till here all are equal, which is 0, right? Both are same. AB are not there and with frequency 0, which is equal to saying that count of both is 0. So MP of 0 is equal to I minus 1. And then start traversing X and Y. So find in the map, update in the map, get the answer, update the index, and similarly find the answer, return the answer. So this way we can find the answer for AB or BC or AC. And now coming to all ABC, we can simply use the same strategy, but with extra 3 variables, count of A, count of B, and count of C. And similarly map of 0, 0, I minus 1, and then start traversing. If this is A, increase A. If this is B, increase B, else increase C. And now find the differences and find the difference pair in the map. If there is not, like if there is, update the answer. If there is no, update the hash map and increase the answer, update the index and return the answer. In this way we can find the answer. If you have any doubts, comment below. See you in the next video.